Today we'll be creating these cosmic megastructures using simulation nodes. Of course, you could depict these as neurons or any other sci-fi concept that you please, but let's learn how we can do this. In our default scene, we're going to bring our cursor to the junction of these two windows, click and drag to create a new window, and we're going to change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, zoom in, select this group input, and tap X to delete it. Now ideally this is a particle system, except we have better control in my opinion, and it's really easy to set up. So initially we need some object from which particles will be emitted. So let's press Shift A, search for an icosphere, and directly plug the mesh into the group output. Now since I don't want this large of a surface area, I want it to be really small from which the particles emit, I'm going to change this radius down to something like 0.1, and I'll increase the subdivisions to 3 so that there's many more faces from which all these particles are going to emit. Now I'll go ahead and distribute some points on faces. So I'll search for a distribute points on faces, plug that in after the icosphere, and then I'm going to increase the density to something like 100, and I'll play around with this in a while. The next thing is actually getting these particles to move away on every single frame. So to get something to move away on each frame, we have to iterate it using a simulation zone. Now we can plug this in here and take this geometry output and plug that into the group output and plug in whatever commands we want to occur on each frame. So on each frame we want to move these by a bit, so we can move things using a set position node. Now we want to move this outward, which means if we actually take their position from the origin and we offset it by that same direction, they'll move outward. So we can get the vector that points from the origin to each point by using a position node. And you'll see if you take this position and plug it into a vector math node set to normalize, you can directly search for vector math normalize, or you can search for a vector math and change it to normalize using this drop down menu. However, then you can plug this into the offset, and that means it'll move by 1 unit in the same direction every single frame. So if we look back and we play the animation, it moves by 1 unit every single frame. So that's all right, but clearly the effect is way too strong. So let's go ahead and search for another vector math scale node. So let's press Shift A, search for a vector math, and change this from add to scale, and simply scale this value down by something like 0.1. Now if we play the animation again, you can see they move out at a constant speed in the same direction they were moving. Now clearly there are way too less points, so we'll increase the density up to 1000, and of course before rendering we'll increase it even higher than this. Now the next thing is, because we're using geometry nodes, since we want to add in more particles every single frame, we have to search for a join geometry, plug that in before the set position, and take these points and plug them into the join geometry. So now when we play the animation, every single frame there's going to be a new set of points created over there itself, and then each point is going to move outward. However, because they're being distributed in the exact same place as we're using the same seed value, it's going to look exactly like they are forming straight lines. We don't want that. We want it to be randomized on every single frame. So we're going to change this seed value on each frame by searching for a scene time node and plugging frame into the seed. So now each frame there's a new seed, and we get these to move out in random directions. So this looks good enough, but you see after a few frames the number of particles keep increasing and none of them get deleted. So that's going to be really hard on our laptop. So we want to delete particles after a specific number of frames that they have existed. For that we need to calculate each particle's age. So to calculate their age, we can create a new attribute, which is going to be fairly simple, and it's going to be similar to how we created a velocity in other simulation node tutorials. We need to first capture the current age, so we can press Shift A and search for a capture attribute and plug that in right after the set position. And for this value, since the age is an integer, it's the number of frames, we're going to change this from float to integer. And now we can take another socket from the simulation input and plug that into the value. Now this is currently just called value, so we need to change the name to age so that we can understand what it does. We don't necessarily require to change it, but it keeps everything organized. To do that, we come to the node tab over here, make sure that we have this simulation input or the simulation output selected, and then change this value over here to age. Now you see the initial age or the default age is going to be 0, and then once it comes in, we can take the age and use it wherever we want, and then we can take this and plug that into the output age as well. Now the age is going to remain 0 on every single frame, but we want to increase this by 1 every single time. So I'll press Shift A, search for a math node, and then just add a value of 1 every single frame. So now the initial age for each particle that's created is going to be 0. Then we are going to capture the attribute so that we can use it for some other purpose, and then we're going to add 1 to the value, and then we're going to send it to the output. That outputted value is going to come back to the input, and it's going to increase by 1 1. So that way we're going to get the age. Now what do we want to do with this age? We want to delete points if the age is greater than a certain value. So let's go ahead and shift this to the side and search for a delete geometry node and plug that in over here. Now we want to use this selection so that not all the points are deleted, but only certain points are deleted. So let's search for a compare node so that we can compare the age with some value. So let's change the type from float to integer and plug the age into socket A, and we want to delete anything that's greater than something around, let's say, 70 frames. So let's plug that into the selection, and now let's replay the animation and see what happens. Remember, to reset everything you have to go to frame 0 or frame 1 and then start the animation again. So now you can see anything that crosses age 70 is getting deleted, but if we just use a single 70, it becomes a harsh border and we don't want that. So we want to give some randomness to the life. So to add in some randomness, we can press Shift A, search for a random value node and change this from float to integer and change the min to, let's say, 60 and the max to maybe 80, and then plug this value into socket B. Then if we play this again, they're going to exist for anywhere between 60 to 80 frames, and that's going to cause not that sharp of an edge, which looks a bit better in my opinion. Now all of these are moving in random directions, but we want to actually align them a little bit to create those cosmic structures. So to align these, we're actually going to use another set position node, and although noise textures are used for creating noise, we're going to actually use the noise texture to create alignment. So let's press Shift A, search for a set position, plug that in after the delete geometry, and then for the offset we're going to use a noise texture. So let's search for a noise texture and let's plug the color into the offset. However, we know that this is not going to give us the result that we want. We're going to change this up a bit by adding few nodes, but first let's take a look at what it looks like. So clearly the noise texture is doing something really weird and it's causing all of the particles to move in that particular direction. Now that's happening because the noise texture goes from 0 to 1. So on average the noise texture moves particles towards 0.5. We want it to stay in the same position and just add in randomness to that. So we have to go ahead and search for a vector math node and change this from add to subtract and subtract 0.5 so that the output of this noise texture goes from minus 0.5 to 0.5, which is centered around 0. So now let's go ahead and replay the animation and see what we get. And yes, now we're getting noise in all of these directions. However, the noise is way too strong. So let's first reduce the scale down to 1 and then see what happens. Now we get some amount of noise in very specific directions, but the actual strength of the noise is too strong, so they all flow in that direction. We don't want all of them to flow in that particular direction, so we want to actually give it some leash on the strength. So for that we search for another vector math node and we changed it from add to scale and plug that in after the subtract. Now we'll scale it down by some amount, let's say maybe 0.2, and this is going to act as the strength of the noise texture. So now that's removing too much of the noise texture and there's too much randomness, so let's increase this to maybe 0.6 and just play around with this till you get some sort of a structure that you like. Now I'm liking this structure, so I think this is what I'm going to go with, but I still want a fewer number of lines being created. So to reduce the number of lines, I'm going to change this scale value to maybe 0.8 and then run it again, and now there's going to be even fewer lines being created. So you can play around with this value till you get something that you're satisfied with, but the next issue that we're going to have to tackle is that these lines are remaining in the exact same positions on every single frame. We want it to slowly change over time, so I'm going to play around with this noise texture by changing it from 3D to 4D so that we can change the W based on the frame number. So again, I'll search for a scene time node and I can directly plug the frame into the W, but that's going to be too strong and you can see that it becomes fairly random again. So to reduce that, I'll search for a math node, change it from add to divide, and I'll divide it by a large number, let's say 200, and that way these lines are going to be formed, but over time the lines are going to change their directions and we're going to get new lines and things like that. I think 200 is a bit too less, so I'm going to reduce this to 100 and that way it's going to move a bit faster. So let's see, you can see this line is being created here and now that line changes, it moves direction a bit, and that just gives it some more life. So I think that looks good enough. Now the next thing that I want to do is actually increase the density even more. So I'm going to go ahead and increase the density to, let's say, 5000 and then replay the animation. So I think that looks really good. Remember, as the density goes high, it's going to take a lot longer for your computer or laptop to calculate it. So be careful with how high you increase the density to. However, this looks good enough in my opinion. So I'll leave it as is. And remember that it takes a few number of frames till we get to the maximum life. So since I have the max life set to 80, when I actually render this out, I want to start it at frame 80. However, if we change this start frame to 80 right now, you'll see that the entire simulation will start from frame 80 itself if you make any changes. So let's say I just change this max life to frame 79. Now, even though I start at frame 80, it's going to start the simulation at frame 80. So we're not going to be able to make changes. So that's why it's best to just bake out the simulation before you change the end frame to 80. Let's change the start frame back to 1. And then if you're happy with this particular simulation, you can go to the physics properties, expand simulation nodes, and bake it. However, to bake it, you have to save the file. So let's go ahead and save it. And since I'm going to be starting on frame 80, I want the end frame to be 80 plus 150 so that it's a 5-second long animation. So I can directly type 80 plus 150 and then I'll press bake. So once the simulation is done baking, it should be able to play back a little faster and you can move on to the next part of this tutorial, which is actually giving these points some object when it's rendered. Because right now, if you go to the rendered view and switch off overlays, you won't be able to see anything. So for that reason, we have to go ahead and instance on points. So let's move the group output to the side, press Shift A, search for an instance on points node, plug that in, and for the instance, we'll just use an icosphere with a radius brought down to something really small, let's say 0.01, and then plug this mesh into the instance. Now you get this sort of a structure, which I think looks fairly cool, even just like this as well. However, we're going to go ahead and texture this quite a bit. So to texture this according to the age, since we do have the age, we can go ahead and capture the attribute and use it in the shader editor as well. So let's actually go ahead and use this age to control different aspects over here. So the first thing that I want to do is actually store the age in an attribute. So I'll search for a store named attribute and plug that in over here. Now, since the age is an integer, I'm going to change this from float to integer and plug this age into the value. Now for the name, I'm just going to call it age, and this way the attribute age is stored for every single point there is. Next, I also want to use this age to control the scale of these points so that points towards the absolute outer edge scale down. So for that, I'll press Shift A and search for a map range node. We know that the age goes between 0 to a max value of 80. So any particle that is alive for 80 frames should eventually get a size of 0. So let's plug this age into the value of the map range and then change this from min 0 to from max 80, because the maximum age can be 80 either way. And then since we want particles that have a lower age to have a larger size, we can change this to min as 1 and change the to max to 0. And then if we plug this result into the scale, particles towards the edge will be scaled down to 0, and that just gives it a nice fall off. Then we have to give these particles their material. So I'll press Shift A, search for a set material node, plug that in after the instance on points, and give it the default material. Now we're going to start playing around with the material, so we need that shader editor tab open. So I'll bring my cursor to the junction of these two windows, click and drag to create a new window, and this time I'm going to change this from the geometry node editor to the shader editor. Now I'm keeping the geometry node editor open over here because I might need it to actually see the attribute and things like that, although the attribute is fairly simple and I won't necessarily require it, but I'll leave it open just in case. And since I want some more space here, I'll just tap N to hide the side panel on both the shader editor and the geometry node editor. Now I'll press period on my numpad to get the shader nodes centered, and I'll zoom in, select the principal BSDF, and tap X to delete it. I want each of these particles to be emissive, so I'll search for an emission node and I'll plug this into the surface. Next, to see the changes occur on these particles, I'll change my viewport shading to rendered and I'll choose all my rendered defaults. So I'll go to my render properties, switch on bloom, and I'll actually change the intensity from 0.5 to 0.02 and I'll clamp it at 4. Then I can go ahead and increase the strength to something really high, let's say 200, and that'll just make them really bright. Now for the color, I'm going to actually use the age property. So let's press Shift A, search for an attribute node, and for the attribute, I have to choose age. So I'll just type in AGE, and remember, this is storing every single point which is not real geometry yet, so they are instances. So I'm going to change this from geometry to instancer, and only then can we use the age value. Now I'll search for another map range node, because again I know that the age goes from 0 to 60, but if I have a color ramp, the factor of the color ramp goes from 0 to 1. So I'll plug this color into the value, and then I'll change the from min and from max from 0 to 80, and the to min and and 2 max as 0 and 1 itself. Then I'll search for a color ramp, plug the result into the factor, and then plug the color into the color. Now since we want particles near the center to be the brightest, I'm going to take this white, drag it over to the left, and then I'm going to change this to a bright bluish color. Then as the particles go to the edge, I want the edgemost particles to be a purplish color, so I'll change this one to a purple. And then in between, for the transition, I'll add in a few blue stops. So I'll press this plus button and change this to a blue, and then I'll change the interpolation type from linear to B-spline so that it's very smooth. And when you're in B-spline, this middle value won't necessarily get seen, so I'm gonna go ahead and add in another stop and change that to blue as well. So by doing that, that ensures that there's a possibility of having blue, but I think I'm gonna add in another blue slot as well. And now we have the particles going from a bright blue in the center to a blue in the middle, and then becoming purplish pinkish towards the edge. So once you're done with that, you can go to your world properties and change the background color to black, just so that you can see what it looks like a bit better. And then you can actually play around with the background. So we'll change the shader editor from object to world, and for the background I'll just search for a noise texture, and we'll actually do something that's very similar to this video over here. You should definitely check that one out if you haven't already. Although it's a completely different technique, the background's going to be fairly similar. Then you can search for a color ramp node, plug the color into the factor and this color into the color of the background, and clearly the white is way too strong, so I'm going to go ahead and bring the black in all the way. And maybe I want the background to be a bit purplish because the brightest areas are blue, so the background areas should be of the darkest color. So I'm going to change this white to a purplish color. Then on the noise texture, I'm going to go ahead and increase the detail all the way to 15, and I'm going to increase the roughness to maybe 0.75, and then I'm going to decrease the scale down to something like 1, and then I'll finally reduce the strength down to maybe 0.02 or 0.2. Once you're done with that, all you have to do is actually set up the camera. So I'll select the camera, press Alt G to clear location, Alt R to clear rotation, and then I'll press RX90 to rotate it about the x-axis by 90 degrees, and then I'll press GY and just move it back a little bit. Then I'll press 0 to go into my camera view, and then I'll go to my camera properties, go to viewport display and increase passport out all the way to 1 so that nothing outside the camera view can be seen. And then I'm going to change the focal length down to something like 18 so that it becomes fairly wide angle. And then once I'm happy with the positioning, remember you can always go to the object properties over here and play around with the actual Y value to change how close or how far you are from the object. If you want to fit in the entire thing, you can just zoom out quite a bit, but I don't want the entire thing to be fit into the scene, so I'm gonna zoom in to about there, and then I'll press Shift A, search for an empty plane axis, and I'll scale that up. Then I'll select my camera, Shift select the empty, or Control click the empty if you're selecting them from the outliner. Then press Control P and set parent to object. Remember, while pressing Control P, you have to bring your cursor to the 3D viewport. Now the camera is a child of the empty, so you can select only the empty and go to frame 80 because we want to start the animation at frame 80. So I'll go ahead and change the start frame to 80, or actually 81 if you want it to be exactly 150 frames ending on frame 130. And before I do the animation, I'll just set all of my animation defaults. So I'll go to my output properties, change my frame rate to 30 frames per second, and start and end frame I can change accordingly. Now my output folder can be wherever I want to save the file. File format, I'm going to choose FFmpeg video, and my encoding, I'm going to change container from Matroska to MPEG-4, and output quality, I'm going to keep it at perceptually lossless. Then on frame 80 itself, I'm going to select the empty and press I, rotation, and then on frame 230, I'm going to press R twice so that I get trackball rotation, and then just rotate it about to some other arbitrary rotation, and then tap I, rotation. So now, of course, just to see the motion, you can go back to your solid view, switch off your overlays, go to the first frame and just play it back, and you'll be able to see the motion. Now, since it's not looping, I've kept the motion at Bezier itself so that it starts off slow, speeds up, and then slows down again towards the end. But yes, I think this motion seems good enough, but I have to see the original speed at which the motion is happening. So I'll change the playback from play every frame to frame dropping, and then I'll just play it again so that I get an idea of how fast we're going to be moving through. And I think this speed is all right. So since that's good enough, I'm going to go ahead and press Ctrl S to save it again, and then press render animation. If you want, you could always switch on motion blur or add in some depth of field by selecting your camera and then going to the camera properties and switching on depth of field. However, all of that is your preference and you can choose to do so howsoever you please. With that, you should get something that looks like this. Thank you so much for watching till the end of the video, and I really hope you learned something and you can create really amazing animations using this technique. If you like this video, definitely check out other simulation notes tutorials on my channel, and remember, I upload videos every single day and I have a huge variety of animations that I create, so I'm sure there's something waiting to be discovered by you on my channel. So until the next video comes out tomorrow, browse other videos on my channel and keep creating, and don't forget to stay creative.